right, folks. This is the last video in this chapter, and we're going to talk about both Uranus and Neptune at the same time. Why are we going to talk about them together? Because quite honestly, they are so similar in composition, chemistry, behavior, that to separate them would be kind of redundant and boring. So how do you tell them apart when looking at them? Uranus is more of a pale blue-green. And it also orbits on a tilted axis, so it actually rotates. Here is its axis of rotation, and it spins like this. Neptune is a little bit darker blue, and its orbit is closer to being in line with the plane of the ecliptic that you and I are used to. So to begin, Uranus is named for the god of the sky, and it is a very, very beautiful sky blue. I have had students who have asked me this question through the years. Is it Uranus or is it Uranus? Well, I admit, I don't know if one is more correct than the other, but I have taught school for many, 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 many years, and so I avoid saying the word anus because it's going to get nothing but giggles. So I have a tendency to say Uranus, and I'll figure out one day if it's Uranus, if it's more exact. One day is 17 hours. Again, very fast for a very, very big planet. And one Uranus year is 84 Earth years. Takes a long time. If you know someone who is 84 years old or older, they have lived through one Uranus year. Otherwise, nope, they have not. Now, Neptune is 30 astronomical units from the Sun. Again, rotates, all the gas giants rotate really crazy fast. One day is 16, or one sol, I guess would be more accurate, is 16 hours on Neptune. And one Neptune year is 165 years. Takes a long time, that distance, to orbit our sun. Neptune is named for the god of the sea, and who is also Poseidon. Poseidon, spelling I'm not too sure about. This is Latin, and that is Greek. So how were these discovered? Uranus was discovered in 1781 by a very famous astronomer named William Herschel. In the 1700s, William Herschel spent a lot of time gazing out into the sky with his telescope, and he actually discovered the planet Uranus. Neptune, it is believed that Galileo actually observed it in 1613, but he didn't understand what he was seeing. So astronomers and mathematicians kept predicting mathematically, because of the mathematical wobbles in the orbits of other planets. As they're orbiting around the sun, instead of just orbiting in nice straight lines, every once in a while they would orbit and wobble because something else is out here that is gravitationally affecting them. And they predicted there would be another planet discovered, which turned out to be Neptune. This was predicted in 1845, and it was first seen by Johann Galle in 1846. So we've known about Neptune for not quite 200 years. They are not terribly easy to see. This is a picture of Uranus and Neptune, and you can tell from both of these that, yeah, those arrows are pointing at Uranus and Neptune, and boy howdy, yeah, in the sea of stars that are out there, something that moves very, very slowly was very difficult to detect. Composition of both planets are almost identical. There is a highly compressed liquid, water and ammonia in the middle. They have a rocky core. Both have a rocky core. Both of them, their outer layers are hydrogen and helium. Now, comparative size. Now, these are, of course, the gas giants, so they are big planets. Jupiter is still the largest. Saturn then is a bit smaller, and Uranus and Neptune are just about the same size. They're very, very similar. For perspective, relative, there's the Earth, so much, much bigger than our Earth. Uranus is about 4 times bigger than the Earth, and Neptune about 3.9 times bigger than the Earth. Both of them have an atmosphere of mostly hydrogen and helium. The temperature on the planets are quite even due to the fact they're so far from the sun. If the sun is the tiny little dot way over here, there's not a lot of change in heating from one side to the other. They're also both rotate kind of nutty crazy fast. Uranus is more of a blue-green, meaning there's more methane, or the methane is deeper in the atmosphere. Neptune is due to more methane near the surface, and hence it is a deeper blue. So it's chemical composition that accounts for those slight temperature differences. Excuse me, color differences. Now, when you were in elementary school, you may have drawn Neptune with a big dark spot on it, just like Jupiter has a big red spot. For many, many years, Neptune had a big dark spot. In the 1980s, it was seen. By the early 2000s, it was gone, and currently it is not visible. But you're going to see a lot of illustrations of Neptune, including the dark spot, because it's like the only interesting feature on this really boring blue sphere. Both Uranus and Neptune's have magnetic fields, but their magnetic fields are weird. They're not located in the center of the planet. The theory is that the field in both were generated by some sort of conducting metal that's outside of the planet's core, that they have a rocky core, and then there's conducting metal outside of that core, which pushes the magnetic field from the center, where ours is, off to the sides. And so they have crazy magnetic fields. Neptune's magnetic field comes out of the lower bottom of its, on the sides, lower sides of it like that. And Uranus's magnetic field is off to like the right side versus the left. You don't need to know specifics, just that their magnetic fields are kind of wacky. So, okay, when Voyager went past Uranus in 1986, it was launched in the 1970s, but it took another decade for it to get out to where Uranus is. It's a long way away. Weird things were discovered. First off, the fact that it has rings. It was not known that Uranus or Jupiter had rings until Voyager got there. The other thing is that we didn't know that Uranus spins sideways to the plane of the plane of the ecliptic. Everything else, if here's the plane of the ecliptic, it spins in the same plane. Uranus is about 90 degrees off. It is believed that early in its orbit, it got whacked by something. Something hit it, and whatever hit it changed its orientation. So Uranus and Venus are the only planets that orbit backward to the plane of the ecliptic. Back to what I was just talking about, how did Uranus get tilted? Well, we think something hit it, or multiple large objects that caused that current tilt. In the early formation, it's a very large moon that pulled it onto its side gravitationally, and then this large moon might have been ejected into deep space. But there's a reason I have a bunch of question marks here. We don't know for sure. There's computer modeling and things like that, but we really don't know. And again, that's one of the reasons that makes this fun. We don't know it all. So, as I said, everything orbits the same direction except Venus is backwards and Uranus is backwards and tilted, which is kind of wacky. Let's talk about moons. Uranus, the god of the sky, it has 27 moons, and they are named for characters in Shakespeare and Alexander Pope, who are two great authors. Miranda, Ariel, Umbriel, Oberon, Tatiana. If you've ever taken Shakespeare and studied what's the name of the Shakespeare play where they're on the island? The Tempest. The Tempest. A lot of these are characters from that Shakespeare play. And this is a chart showing all of the moons of Uranus, and there's a lot of really tiny little ones all over there. This is a new one they found. They named it Cupid, which was kind of cute. Neptune has 14 moons, and Neptune is the water god, and so, of course, his moons are named for water spirits. Larissa, Nadia, Triton, uh, Proteus, yeah. Okay, I don't know all my goddesses as well as I should. So that's going to complete our discussion of the planets. Why aren't we going to include Pluto here? Because sweet little Pluto got declassified into a planet, to a dwarf planet, and we will talk about that next time. See you later, alligators.